Taylor series and Maclaurin series. So the Taylor series is an infinite expansion of a function that goes from summation n equals 0 to infinity Cn x minus a to the n, where Cn is the nth derivative of the function evaluated at a divided by n factorial. On the other hand, Maclaurin series is a special case of Taylor series when we replace a by 0. And then we find our Cn in the same way. Instead of finding the evaluated derivative of the function at a, we will evaluate at 0. All right, so we have a problem here now to find the Taylor series of f of x equals x to the 3 at x equals 1. And we want to explain what is the meaning of f within parentheses n. This is basically showing us the order of derivatives. So if you see on the right hand side in here that we have, when we are saying f1, that means first derivative. f2 is second derivative, f3 will be third derivative, and so on. So we are trying to find what is f0. So f0 meaning is the zero derivative. That means original function. So c0 is original function evaluated at x equals 1. So in this case, we will write here 1 for Taylor series, but 0 for Maclaurin series. So now you know f1 will be 1 to the 3 because our function f of x is x to the 3. So that gives me just 1. So that's my c naught. What is c1? Take the derivative of the function. So we are just saying f prime 1 over 1 factorial. And as you know, your function f of x is x to the 3. F prime x gives me 3x squared. F double prime x is 6x. And then f third derivative x is giving me 6. Next, if you take the fourth derivative at x, that is 0, so we can stop. Okay, so then f prime, we have got 3x squared, so f prime 1 will be 3 over 1 factorial, which is 3. What is c2? Second derivative, which is 6x. So 6x will be 6 times 1 divided by 2 factorial. So that gives me 3 again. c3 is third derivative, which is 6, and factorial 3. So then factorial 3 is again 6. That gives me 1. So we got all the values for c0, c1, c2, c3. We'll plug it back in the function. c0, which is 1, we see here. So we plug for c0 plus 3 times x minus 1. 3 is our x1, c1 value. c2 value is 3, then x minus 1 is squared. c3 value is c1, then x minus 1 to the 3, and c4 goes to 0, and all other coefficients will be 0. So stop here. And now what is happening, x to the 3 we have in the left side, and we put equal sign. The right hand side we have polynomial terms in here. If you, for example, expand x minus 1 to the 3, x minus 1 to the 2, and distribute 3's, and after you simplify, your complete result will come out as x to the 3. So x to the 3 is written as a Taylor expansion on the right hand side. Thank you.